Okay, good evening. So today I'm going to attempt. Today is the 8th. I just going to solve a few problems. I actually had a bit of, you know, long day today, but the most important thing is showing up and solving all these data structures and algorithm questions and improving each day. So, which is why I'm here today, and I'm going to go over two important questions that I solved yesterday, and also I'll here. So also I'll explain. So these questions I solved yesterday, although the second one, which is the widest vertical area between 2 points, was a bit tough. It was a bit confusing at first, but then I went through um, the editorial and read the answer there. So, and I understood what the question was asking. Now, what I'll do now is I'll go over it again and see how well I'll do explaining this solution. Right. So, here's what I did yesterday. I'm just going to erase this graph. I'll keep every other thing here. So, let me come here. Sorry. So I'm going to erase this graph. Yeah. So I'll draw another graph, but yeah, I will do that later. So let's read the question again. For the first question, this is the richest customer wealth, right? So this question, okay, you know what? Let me just go over the question. How do I do that? How do I do that? How do I do that? I can't create multiple instances of the Excalibur screen. It's just one that I can have, so I'm not sure how. And I don't want to. Okay, you know what? Let me just remove this. Um, Here. Okay, so the richest customer wealth problem. It's a 2D array problem where um we are being asked to return the maximum total in. So here, let me just copy this. So we have a 2D array, right? A 2D array that represents the account of each customer. So here we go. I'll say here. Oh, okay, that is better. All right. So here is one customer's account, right? Here is one customer's account. This array here. Let me use a different color. So this represents one customer's account, and this whole array too, right, represents another customer's account, right? And these numbers here represent the amount of money the customer has in their account, right? So this entire array represents the accounts of all the customers. I'll say in a bank or somewhere. So the question is asking to return the total, the highest amount a customer has in this account array here. So the solution to this question is to go through each customer's account, right? So this is one customer's account. The entire array is one customer account, and the second array is another customer's account. Now, and calculate. So the first step is to go through each customer's account and calculate the sum of all the amounts they have in their account, right? So we'll do 2 plus 1 plus 2 plus 3 for the first customer. This is 6. And then 2 plus 3 plus 1 for the second customer, 2 plus 3 plus 1 for the second customer. This will give us 6 as well. So the highest amount here is 6, because 6 is equal to 6. So we return 6, which is the highest amount uh, the a customer has in the in this account array here, right? If this was 2 3, and then let's say this was 5, right? Then we'll do 6 plus 5, which is equal to 11. So we'll return 11 as the highest amount a customer has in their account. So this is the solution to this question. And given the fact that we have to go through each customer's account and before we calculate the total of their the total money they have in their account, it means that first of all, to go through, we have to loop through each of the items, each of the accounts in the account array, then loop again, right? Loop inside the our upper loop to calculate the total, right? Which is summing up each of these items in this array here. So we have an array within an array, and to target the second, the items inside the second array, we need to run a loop inside another loop. So yeah, that is the answer for the richest sum, the richest customer wealth, and this is the Python code for it. Let me increase this a little. I'll just bring this up a bit. Yeah, so this is the solution for the question. So here's what I did. I ran an upper loop to look through each account, and an inner loop to sum up the amount of money a customer has in their account, right? So yeah, that is our first solution. Now the second question, sorry, was on the widest uh, vertical area, right? So I'll go back again, see if I can get my graph back. Hopefully, yes, I did. I got it back. Okay, so I'll just okay. I'll just erase this one here so that I have space to go over and explain this question again. This question is kind of tricky, but at the same time, when you know really understand what they're asking, you just realize that it is not confusing. It's kind of misleading, yeah, at first when you read it. So I'll create my graph again. Um, Let me just use this color here. Okay, that wasn't right. Here, right. So I have this one here, and I'll have another one going this way. So here. Okay. Now let's read the question again and see, what the question is really demanding of us. From us, sorry. So, given endpoints on a 2D plane, right, where points I is equal to xi and yi. So, a point on the 2D plane is a point that goes from the x-axis, which is this xi, and then to the y-axis, so which is this yi here. Return the widest vertical area between 2 points such that no point inside the area, such that no points are inside the area. Sorry. So return the widest vertical area between 2 points such that no points are inside the area. A vertical area is an area of fixed width, right? An area of fixed width extending infinitely along the y-axis. So infinite height, right? So it goes all the way, right? The widest vertical area is the one with the maximum width. This makes sense now. The first time I tried solving this question, I had an issue understanding it, but now it actually makes sense. So let's say note that points on the edge of vertical area are not considered included in the area. On the edge of a vertical area, what's the edge here? Is it on top of the y-axis? Like, okay, yeah, we don't really mind about those ones yet. So let's go. Oh, we actually should care about that because I want to use this example here. I used this yesterday and it was pretty simple. So let me use this example instead. So yes, here is our first test case. We are given these points here. We have points 8, 7, 9, 9, 7, 4, and 9, 7. And the maximum, the widest vertical area here is 1. And the widest vertical area is an area of fixed width extending infinitely along the y-axis. The widest vertical area is the one with the maximum width, right? So let's go and find out what that is. So I've copied some points. I'll just remove this one here and place those here. Oh, okay, this is not it. I want to use this other one. I want to use this one here. Yes, since it is longer and easier to visualize. It's not easier, but like it will give us more to talk about. Yep. So here we go. All right. So I'll start marking, the different points here, right? Um. Well, this image is no longer relevant to us. I think I should just keep it there for sake of, explaining what it is. So we can, first of all, let's look at the different points on the x-axis. So we have 3, 9, 1, 1, 5, and 8, right? So we have 3, 9, 1, 1, 5, and 8. So I'll just use those here. I'll put this one here. I'll call this 1, 3, yes, 1, 3. Okay, you know what? 1, I'll just do it this way. 1, 2, then 3 here. 4, right? Do we have 4? We don't have 4, so I'll put 4, 5, 6, 7, 8. So we have 8. So 3, okay, there's up to 9 here. So 3, 9, so I'll put 9 here. 3, 9, 1, 1, 5. So 1, 2. So we have 5 here. 5 and 8. 8 is here. Okay. Now the next one will be for the y-axis. So we have 1 still. We have 1. And then we have 0. 0 will be here. Right. 0 will be there. We have 1 again. Then 5. Sorry. We have 0, 0 again. Then 4. Right. So we have 2, 3, 4, right? 2, 3, 4, and then yeah, we have 3, 2, 3, 4, 5, 6, 7, 8. So let's do it this way. So we go to 2. Do we have 2 here? We have 1. we have 0, we have 0, we have 4. So 1, 2, 3, 4. So 4 is here, and then 3 is here, so put 3 here, and then 8. So 5, 6, 7, 8. I'll put the 8 here. All right, so this is a representation of this graph. So I'll put the different points here. So the first one will be 3 to 1. So we'll go this way. I'll use a different color. Let me use this blue one here. Okay, so I'll go 1, 2, 3, 4, 5, 6. Okay, so here, this is our first point. I'll put it like this. And then the second point is 9, 0. So we have 9, 0. So it will be here on this line here. That's 9 and 0. And the third point is 1 and 0. So the third point will be somewhere here like this. The fourth one is 1 and 4. So we go 1, 2, 3, 4, 5. So we have 1 and 4 here, right? This is 1 and 4. The fifth point is 5 and 3. So we have 5 on the x-axis and 3 on the y-axis. So I'll just go like this, like this. Okay, so we have our fourth, I think, fifth point. Okay, now the sixth point is 8 to 8. So 6, 7, 8. So 5, 6, 7, 8. So this is 8. I'll go here like this and come down here. Sorry. I think visualizing this will actually make a lot more sense. So let's go here. This is 8. Let me put like a different color on the points so that they look different. So we have the second point here, we have the third point here, fourth point here, another one here, the other one too, we have it here. So we have 6 points in this array. So 1, 2, 3, 4, 5, 6. Okay, that's complete. Now the question says we should return the widest vertical area, right? The widest vertical area is an area of a fixed width, right, extending infinitely along the y-axis. Now if we look at this, right, let's take this point here, the first one, 3 to 1, right? 3 to 1, okay, let me not use 3 to 1. I'll use 3 to 5, right? First of all, the widest, okay, let me use any point. Actually, I can use any point I want, because the question says a vertical area is an area of fixed width, right, extending infinitely along the y-axis. So regardless of how long this y-axis gets, right, the area will always be a fixed width. So if we did something like this, if we extend this y-axis all the way, right, all the way, 1, 2, 3, 4, 5, 6, we just go all the way up, right? Each one of these, let's move all of them upwards like that. We move this one too all the way up, this one all the way up, right? Now here is the width, right? From 0 to 1 is the width. So the width is basically 1 here, and this is another width here from 0 to 3, which is 2. This is another width here from 3 to 5 is 2. This also is another width. Okay, so we have this point here, although this point is on the x-axis, right? Yes, we can still extend it all the way, right? Even though it meets here, we can still go all the way. So this one too, this is 3 and this is 1, right? Now we already know the fixed width of one of each one of these points on the in the plane, right? This is a 2D plane. So the next thing we need to know is the widest vertical area, right? Is the one with the maximum width. The widest vertical area is the one with maximum width. Now, um, let's see. The question also says return the widest vertical area between 2 points, right? Such that no points are inside the area, right? Okay, so now the catch here is we can first of all find the maximum width of the widest vertical area, right? Although vertical is being mentioned, we are not really working with the vertical area. We are working with the area along the x-axis, right? So, like I said, this is 1, this is 2, this is from here to here is 3, from here to here is another 2. 1 to 3 is 2, 3 to 5 is 2, 5 to 8 is 3, 8 to 9 is 1, right? All of these are points on the plane. Now, the widest vertical area also from the problem, what the problem wants us to return is the widest vertical area between 2 points so that no point exists inside the area. So, we know that this here, right? This here is one area. This is another area. This is also another area. This is another area. But if you look, okay, this is also another area, right? Now, the question wants us to return the widest vertical area so that no point exists within the area, right? You can't, so what they mean is if we are looking between 2 points, let's say the point x, this point here, 1 to 4, right? 1 and 4, right? 1 and 4 and 1 and 3. Sorry, 3 and 1, right? So let me do it this way. Between these 2 points, we have, I'll go like this. We have point 1 and point 1 to 4, and on the x-axis we have 3 to 1. Okay, so this is point 1 and point 2, right? Now between these 2 points there is another point here, right? Between those 2 points there's another point here, which is this where y is equal to 0. So we have 1 and 0 here like this. So this point here is between the points, I'll call this A and B, right? So this point here is between these 2 points, and the question doesn't want us to return the widest vertical area between 2 points such that there is a point in the middle. The question doesn't want us to return that, so we want to return the widest vertical area such that there is no point in the middle. So how do we do that? We continue looking, right? So we can see already there's a point between this one, so we can't look at this place here, but between this here and that one, right, between these 2 points there is a point. There is no point in this plane here. So between 1 and 3, right, there is 2. So this is the widest area between these ones. So it's 2, but we still have more points in the plane, so we can't just say 2 is our maximum value. So we'll continue looking, right? So we'll say, okay, at this point here we are 3 to 1, 3 1 here. This is this point here. So between 3 1, right, between 3 1 and 5 3, the area here is 2, so the value here is 2. So we still 2 is still equal to this, so this is not the maximum yet. We'll keep looking, right? Between 5 and 8 we have 3, right? Our value here is 3. So this already is bigger than the previous maximum that we found, but we are not still, done with the lookup. So we have to continue until we reach the end of the points that we are given, right? I think my here, let me just shift this to the right a bit. Okay, so we'll keep looking until we reach the end, right? Until we reach the end. Now we are at this point 8 to 8, right? 8 to 8 and 9 0. So what is the width of this this point here, right? The width here is 1. So already we've reached the end of the points that we've been given on this 2D plane, and so far 3 was our maximum value that we found, so we returned 3 as our maximum. Yeah, so this is how we'll find the points, the widest vertical area between 2 points, right? Because this point here is this one here, and this is another point here, so the area between these points is 3. Simple. I actually struggled with this. Let me confirm if that was the value. Yes, so they returned 3, right? So yeah, it was quite easy, but requires a lot of practice to actually understand the question. And another thing I would like to point out is coming. So to solve this, right, you can see we are looking from the start, right, from the smallest possible points that we find on the x-axis. So meaning we need to sort this array, right, this to the array, right, based on the value of the first item in the array, and we can use a lambda function to do that, right? So which is what I did here. So lambda dot sort, we are returning the x of I each time, right? Because this here will look into the array, but we have another array inside the array, so which is why we are providing x or x at 0 as our key for the sorting operation. Then we can now loop through the array and subtract the previous points from the current one, right? The previous points from the current one, and each time we'll get a new value, and we'll find the maximum and return it at the end when this loop is done. So that's the solution for this question here. All right. Okay. Sorry. Let's look at the next question. So this question is asking us to shuffle an array. I'm not sure. I haven't solved this question before. Okay, I did. Maybe I actually failed because I didn't submit this. It didn't show as solved, right? Let's run this first. Let me see if I actually solved it. Okay, so it's a wrong answer. So I'll go over it again and try and solve it myself now, this time around. Alright, so given an array nums, right, consisting of 2n elements in the form of x1, x2 all the way to sn, and then from y1, y2 all the way to yn. Okay. Return the array in the form of x1, y1, x2, y2. Okay. That is good. So we have an array nums here. That is 2, 5, 1, 3, 4, 7, and then n is 3, right? And we are told the array consists of 2n elements. So the length of this array will be n times 2, right? So let's see if that's true. We have 1, 2, 3, 4, 5, 6. Yes, 2 times 3 is 6. So the array has a length of 6, which is good. So we want to return x1, y1, x2, y2, all the way to xn, yn. Interesting. Well, let me copy this question here and try, understanding it. So I'll click on this. Yep, and come back here. So here's my plane. Use this color here and enlarge this. All right, let's start. So norms, right? This is an array of numbers we'll be given, and we want to arrange we want to shuffle the array. Basically, we want to rearrange the array such that it appears in the form of x1, y1, all the way to x and yn. All right, so first of all, the array has a length of 3, right? So a length of 3. So if we are given n, right, n is 3, right? N is 3. Let me go back here, because so we want to return consists of 2n elements. Okay, 2n elements, right? 2n elements. Well, what does that really mean? Let me close these questions here. So 2n elements, 2 times n elements, right? If n, that means n is like, is half, right? Half of this array here. So this first half will belong to y, this second half will belong to x. So I'll put x here properly, x like this. Yeah, because the entire length of the array is 2n, right? The entire length of this array is 2n. So n being 3 means half, right? So we have 3 and 3. So 2 times 3 is 6. Now, we want to return the array such that x of 1, what is x of 1? Is this one here. So we'll have something like this. At the end of the day, we'll have x1. So x1 is, let me start. x1 is 2. What's y1? y1 is 3. x2 is 5. y2 is 4. And x1 again is 1. And y3, sorry, is 7. So this is what we want to do at the end of the day. Right. Yeah, so I'm thinking of one solution, right? Are there any constraints? So the constraint says so n will always be, at least 1, and also up to 500. Interesting. So norms the length here is equals to 2n. Yeah, norm of I can be any number between 1 up to 10,000. Okay. One way one solution I have in mind. We are not sorting in place, right? So which means that we can have like a separate bucket here. That will just call this a bucket, and every time we loop, right, we'll take the first one here and put it here, and we'll look at the first one of y and put it here, and so on. So we'll use one loop to do this operation, right? Yeah, I think that will work. that work, but the question is not asking us to the question is not asking us to, sort it in place or shuffle it in place. So that is a possible solution, right? We just create an empty array. We create an empty array like this. I'll just use this blue color here. An empty array here. I'll call this X, right? And then we loop, right? We loop based on the value of n, right? N that is given to us. So our length, the length of our loop is going to be n. It's going to run n times, not not the length of this array, but n times, so that we can point at each one of these here, right? Each one of these in this category here. So when n is at 0, right, we'll just do so we'll loop based within this range. So I will use n as our range here like this. Okay, that's very tedious. Okay, so I'll do range. I'll call this a loop I range of n, right? The range of n. So this, since n is equal to 3, so it will go from 0, 1, 2, which is what we are looking for, because n here should the last item here is n minus 1, right? So which is 2 here. 3 minus 1 is 2. So here's what we're going to do. So when I is equal to 0, we'll just take the first item here. So we'll do n at I, right? We'll append it to this array. N at I, we'll append it to this array. And then the next one will be what? So when we look to the other side, right, n minus 1 plus 1 will be the value of this one here. So n minus 1 here plus 1 will come to this place here, right? So this value, the first item in the in this how do you call it, in this y section here, the other side, right, is going to be n. The value of that is going to be n. So I'll just do so 1 minus 1 plus 1. So I'll just say n. Okay, let's call this nums. This is nums. This will represent the array. So I'll do nums again. Nums at so nums at n minus 1 plus 1, right? The next one, this will be n plus 1, and the next time this will be n plus 2, right? And n plus 1 is going to be 4. So is this the fourth item in the array? N plus 1, 0, 1, 2, 3, 4. Yes, this is the fourth item, and this is the fifth one here. So minus 1 plus 1. So we do plus 1 first, right? So we'll do n. So I is going to start from 0, right? So yeah, we'll do n plus I, right? At the end of the day, this will still return n for the first iteration. So the second iteration, I will be equal to 1. I want to do n plus 1 here. This will be 4, right? This will be 5. So here, this works. This actually works, but we are creating a space in our array. I mean, in our solution, right? This is not. We are creating extra space, but the time is based on n here. This input here. The time our operation takes is based on n, so it's going to be linear. N can change at any time. N can be any value. It's not constant. So yeah, let's try that and see. I actually did something before. Let me look at my solution and see what I did wrong. So I said j equal to n. All right, good. For I in range of 1, so I'm starting from the first element. If I is equal to n minus 1, oh my god, what is this? Nums I, this might make sense. Let me actually take my time to read it. So I'm incrementing j each time, right? Which means I'm looking at um the second half of the array, right? Which is y, where y is. Okay. So if I is equal to n minus 1, why am I doing this? If I is equal to n minus 1, if I equal to n minus 1, well, which means I'm at the end of the x section, right? So nums of I, right, at that position, and the next one should be nums of I plus 1. So I'm changing the position. This part works, but this part I'm not sure. What was I doing here? I'm saying, okay, if I'm at the end of the S section, right, then I want to switch the last I plus I here is going to be the last one here. So the last one there, right, and the next one I want to switch them, right? So I want to switch the position of this, and also I want to move to the next one. Oh, this is bad. Okay, I understand what I was trying to do here. It's quite naive, right? Well, if it just came from a logical point of view, because I wasn't sure how I was going to target the last two elements of the array. Because here, all I'm doing is I'm switching positions, right? But this is wrong, right? This is wrong. We don't want to. Okay, this is not wrong because I'm starting from the first elements. So I'm switching positions with the first element, which works. But then this side here was the headache. Okay, yeah, that's not bad. So let's apply the new solution. So first of all, I want to create. I'll say. Um, so we are shuffling, right? I'll just call this shuffled. Shuffled. Shuffled is equal to an empty array, right? So for I in range of n, right? N is an integer, so we don't want to do range length of n. So yeah, so range n, right? So all I would need to do is to just say shuffled dot append. Although this is like, I'm not sure if it's shortcutting the solution, but let's see if it works first before we can judge. Um, judge using built-in functions. But yeah, I mean, this is not a cheat, right? This is not like using sum to find the sum of the items in an array or something like that. So yeah, this still works in my own opinion. So I'll say uh, nums at I. So we are in the x part um of the array now, right? And then we want to look at the y part. So the y part will be nums, right? Nums at n plus I, right? And what are we returning something? Okay, so we are returning the array. Yes, we need to do it this way. True, we need to do it this way. We need an array, right? So we need an array to return. So shuffled here like this, right? So let's see if this works. Oh, I'm doing plus one instead of plus I, sorry. Right. List append takes exactly one shuffled dot append. Okay. Oh, well, if we append this, then we want to append this one too. But that's not good, right? How do I append two items like directly? Because I could just do this one too. I'll just duplicate that and say, okay, I want to append this one as well. Right, so let's run this and see. This will work. It works, right? But is doing it this way correct? Good. Is there a proper way I can append? Let me see. Append two items into list in Python. In Python. How to append multiple value in a list, right? Um, you can use sequence, right? So, to extend the list by multiple values from any kind of iterable. I don't want it this way. Oh, somebody's doing this. My list, new list. So another solution is to unpack both lists into the new list and assign it back to the copy of the original list. So here, my list. Interesting. Interesting. This is usually list comprehension. I don't think I want to use list comprehension. Let's see if this works. Unpacking. Interesting. So okay. Well, for how many lists can this work for, right? Can it work for? So this takes your old lists and then add in the new list. Yeah, but well, it doesn't work. It doesn't work. It doesn't work this way. Because now we need to always remember the last values that we had in the former list before adding a new one. But I want to add, oh, well, I still want to add two items at the same time, not an array of items, right? Or I just create an array. Okay, let's try that. I think that this could work. So I'll do this instead. I'd say so shuffled, right? So want to take it this way and assign it to, so see shuffled, right? And then here like this, I'll just put nums at I and nums at n minus I. Oh, n plus I, sorry. N plus I. Okay, let's see if this will work. Hopefully it does. Yes, it works. So We can replace this with this and it works just fine. So let's submit this. Terrible solution. Are you kidding me? 5. What? At LeetCode does this sometimes, which is crazy. So let's submit one more time and see what happens. Only 5%. Are you serious? Interesting. Oh, I see. You know, well, the reason why this is like this, I think. Wait, let me refresh this. Oh my god. Will my solution be thrown away? Okay, it's still there. Good. 70 for the runtime. It's not bad, right? Let's just run this again. I think it's because of this here, because we are unpacking and so on. But let me submit again one more time to see if the value will change. Um, Values did not change, although you can see this went up from 5%. I mean, in terms of space, I don't really mind. I know it is bad because we are creating a new space, but is it possible we shuffle it inside one array without creating an additional array? Right. Let me try this solution again and see if this will work. Well, this is actually better in terms of memory. So unpacking an array here was really bad because we are creating another array inside the array before packing. Okay, okay. That is bad in terms of space. This solution here is bad. So we just append and it will work just fine. Alright. But in terms of time, it is still not good. So how do we improve this in terms of time? Well, I think it will always be based on the value here, right? And looking at this, selecting an item at a specific index is always going to be a constant time. So, the time complexity for this solution would be bad, would be linear, right? It's always going to be based on the value of this input here. Yeah, I don't think that's all bad. Well, let me look at other people's solution. This just choose Python 3 to actually understand what's going on. Easy, beginner friendly, beats 85.76%. Interesting. Let's see. We could learn something here. Time complexity is O of n, right? This is literally the same thing. And how is this beating 85%? Is it in terms of space? Okay, so C++ 65%. And what's my solution? Submission 73%. I think it's doing it in terms of space. Let me just confirm that here. I'll just copy this and replace it with mine and see what happens. Submit. Wow. 54. Hey, something is wrong with LeetCode. Something is literally okay. You know what? I think when you have comments in your code, that might be counted as well, right? Because I don't see how his solution is different from mine, even though he's creating, new. Yeah, I mean, it's just using a while loop. It's literally the same thing. So how is this dot? It was 54, right? 54 millisecond. Let's see. Let's submit this again. I think there's something wrong with it. Good. Okay, I give up. There's actually nothing wrong with. Wow. Wait, I removed this before. So why did they come back? Maybe the comment is just adding extra time to it. The comment isn't. Okay. Well, that's interesting. Okay, so more challenges. This one is being suggested. Let me not go out of my original plan. So I've done this, and that. Okay, so let's solve one medium problem. I've been solving easy, so let me try a medium problem now and see how well I'll do with a medium problem. Okay. Uh, Let me see. I'm just trying to check if my live is still going on. Okay, it's going on fine. Right. All right. Okay. 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 Wow. Okay. I wasn't expecting this, but yeah, this is definitely good. Let me see. Whoa. What is it called? Array design matrix. Hmm. Okay. I'll try it and see how well I'll do with this. Never seen this question before, but yeah, let's give it a try. Hold on. All right. Implement the class subrectangle queries, which receives a rows by columns, so rows by calls rectangle as matrix of integers in constructor and support two methods. Update subrectangle, so integer, it takes a row, column, row 2, column 2, and a value. So this function here updates all value with new value, right, in the subrectangle whose upper left coordinate is row 1 column 1 and bottom right coordinate is row 2 column 2. Get value int row, int column, return the current value of the coordinates row col from the rectangle. So this gets value. So okay, row and column. So the input is, so inputs can be subrectangle queries, right? Subrectangle queries, which so it receives a rows by column. Okay, so we are dealing with like a, this is row by column. What kind of array is this? This is one. Whoa, hold on. What is this? So 3, 2, 2. Interesting. So let me read this to myself and see what happens. So implement the class who update all values with new value in the sub rectangle whose upper left coordinate is row 1 column 1 and bottom right coordinate is row 2 column 2. Subquery rectangles takes the rows and columns as, you know, matrix of integers. So if we instantiate sub rectangle, it can receive rows and columns. Get values 0 and 2. 0 and 2 will be 1. Okay. Update sub rectangle. So we want a rectangle at 0 0, right? 0 0, which is column, right? Is the column, row and column. So each of these are rows. So 0 0 is here, right? So we want to get this. I want to represent return 2 5. So what's this? 2 and 5. Get int row, int column. So update. By the way, this is not the value. It just means when we instantiate this function here, we'll get, you know, some form of outcome. So we have to instantiate it with a list of lists, right? With a 2D array. So a list of lists. What's the, you know, smallest possible example that we can use in order to understand this? So I'll use this here. Let me copy this. I still don't really get the question, but I kind of have like a little idea. I'll just remove that. I'll put this here and then increase this. Now, so here, let me shuffle sub rectangle. Okay, sub rectangle queries. Oh god, my OBS just got disconnected. Hopefully it doesn't do that again. So get values, right? This is a function that receives an you know, an array of arrays, right? But well, is this really a rectangle? A rectangle has, you know, let's this might be misleading, right? Because if you are thinking in terms of rectangle, right, this you with this is just going to cause, problems. So because, well, this is not a rectangle. Definitely this is not a rectangle. Rectangle will have, four sides, whereby two sides are equal. So yeah, this is really nothing to do with rectangles, at least in my own opinion. Yeah. Now, well, I would like to represent this in this way. So the first array will be 1, 2, 1. The second one will be 4, 3, 4. The third one will be, oh, sorry, YouTube warnings. 4, 3, 4. So I'll have 3, 2, 1, and 1, 1, 1 here. So all of this is the input that our array, I mean our class here, this subrectangle query class gets in its constructor, right? Good. Now, um, so update subquery subrectangle, right, takes an integer row, column, and another integer row, and then it takes two rows and two columns with the new value we want to update it with. Okay, why is that though? Let's see an example. So um an example would be 4 by 3 rectangle. Wait. Oh, I see. Okay, my bad. This this here, this entire thing represent the rectangle, right? This is our rectangle, and you can just think of it as the rectangle having, so this is the rectangle, right? And we have like different points on the rectangle, right? So we have one here from one, let me put it in the middle properly. So I'll go this way like this. So one, 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 and then 3, 2, 1, 4, 3, 4, right? And then 1, 2, 1. Well, that is what is there. So, okay, we know what our input actually looks like. Okay, good. Um, so what's the next thing is to update sub rectangle, uh, update sub rectangle, right? Update sub rectangle. So we take a row. So the reason why we take two rows and two columns, okay? So if this is the entire rectangle, right? A rectangle can be formed from this point here, right? This is one row. This is a column, right? Hey. So we go from here to oh god. So this is one row, right? This is one column, right? And if you connect this, it will give you um it will give you the a rectangle. So this is a sub rectangle of the whole rectangle that we have here, right? So what's the next thing? So update sub rectangle means if we take a point at the row 1 column 1, so we have row 1, this is row 1, and this is column 1 here. or column 1 can go from 1 to 4, or row 1 can be any point. So I can go from 4 to, it's based on the value that we get from the input, right? So row 1, column 1, right? Row 2, column 2, and the integer value. So update all values with the new value, right, in the sub-rectangle whose upper left coordinates row 1, column 1, and bottom bottom coordinates is row 2, column 2. Oh, okay. This is beginning to make sense. So if row 1, column 1, right? Row 1, column 1. So if row 1, column 1 is, so this will be row 1, column 1, right? Although this will not always be 1, so I'm just using this one as an example. So this will be row 1, column 1, right? It will be the value at this point here. First row, first column, this is the value here. And then it takes 4. So yeah, let's take a look at an example. So if we say we want to update here, we want to update 0 0 3. So this is the column, this is column, this is row, column, okay. And then we'll update all the values at that point to 5. After this updates, the rectangle would look like this: 5 5 5. So how many rows do we want to update? It says what? Sorry, let me give myself another 10 more minutes. Scripts. Okay. This shouldn't be hard, right? At least the only problem I'm having is the row 1, column 1 coordinate the upper left. But what when we provide row 1, column 1, row 2, column 2, right? Yeah, if I'm replacing this by a value of 5, right? Let me use this rectangle again. So which rectangle are we using here? We are using this one here, right? Why is it being updated to 5? Oh, okay. Sorry. Third 0 0 3 2. Let's see. 0 0. If it's at this point, 0 3, right? So hold on. 0 and 3. So meaning where updates. Let me copy this one. The update string, it takes a row and a column, a row and a column. So if we pass in pass in 0 0, right? It means first column, first row, first column. So this point here, this point here, and then we said 3 for the row, right? So 3, 1 2 3, okay. And then we are taking 2 columns, okay. 2 columns, 1 2. Okay, okay, this is quite clear now. So meaning we are updating all three we are starting from this point, updating all of the columns and rows by a certain value, 5. Well, how do we actually know that? Okay, so basically what I'll do is we need to know how many rows we want to update, right? The number of rows, row 1 and row 2, all those are two different values. So if we know how many um rows we want to update, we'll know the rows are basically each array um in the matrix, right? These are rows, right? So this is first row, second row, third row, and fourth row, right? Now, if we look at this, when we look at this array, sorry, when we look at this update here, this first, where's the other one that here it means we want to update 3 rows, right? And then 2 columns, 2 columns from the first ones, right? From the first row, we want to update 2 columns. And we already know that counting in programming in computer language, we start counting from 0. So if this is 0, we'll go 2, we'll go 1, sorry, 0, 1, 2, 3. This is our third row, right? So it means we are targeting all the elements in this row. And then how many elements are we targeting in the columns, right? So we are targeting up to 2, right? 2 will be how much we have to look, how many elements. So again, we start from 0, 1, and then 2, right? So here is 2. Now let's look at a higher value to see how the calculation should be done in terms of determining how many rows we need to update. So here we have 3 and 3, right? And then 0 and 2, but we want to update everything with 1. 3 minus I wanted to say 3 minus 3, right? Okay, let's just do it this way. So we want 3 3 and update it with 10. Let me copy this, right, and paste it somewhere here. I'll just paste it at the bottom. Okay, so so the first row 3, right? So 3 3, where is 3 3? 3 3 will be somewhere here. I'll use this color here. So we have 1 or 0 1 2 3. So 3 here, and then 3 3. So this is row 1, row 2. So this R1, R2, meaning we are going to update values starting from this point here. Hold on. R1, R2. I mean, get value is not even our issue. It's how we update the rows and column. So row int 1. I say 3 and 3. 3 means third row, right? Which is literally the last one in computer language. The last one here, right? But what happens to the second 3? Because we can't say it is something along this axis. That's not. So 3, 3. Well, it means we are updating the last array, right? But how do we arrive at that conclusion? This is 2, right? So, hold on. Let's say from this is 3. What is 3 really? 3 is 3 plus 3 divided by 2, right? But how reliant is this equation? I know I can solve this question, but the issue here is knowing where to start from. Start the update from. Oh, well. I really believe I can solve this question. I can. Subrectangle queries. We want to update this value. When we're using 0, 0, and 3, right? It meant that we're updating 3 rows. So meaning we're adding this plus that, right? Updating 3 rows. 3 rows. But when it's 3, 3 now, means we are updating the last row. So 3 minus 3 is 0, right? The last row will be at 3. So 3 plus 3. Is it? Wait. Now we can't do it that way. How do I determine which row I need to update? Here it's pretty simple when you look at it with 0 and 1. But if you do the same thing here, you will not get that same value. I mean, for the columns, it's quite easy, right? So here we know we are updating 3 columns, or 2, starting from index 0. Oh, wait. Starting from, right? Are we starting from 3 and stopping at 3? Starting at 0 and stopping at 3. Wait. If we start from 3, meaning we start from here and we stop here. So we are still at this point. If we start from 0, right, and stop at 3, that means we move all the way to 3. But how do we know, how do we know that the how do we determine that it's coming? We start at 0 here. It's already 9. Shit. we are looking inside the array and we want to know, okay, if so the last, let's assume the last array is telling us is our starting point, right? Where we need to start from, right? If the last array tells us where to start from, then we know that, okay, it's always going to be our starting point. So it's always going to be how many, from how many points we need to go upwards or downwards. Um, so in the case where we are at 0 0, that means we have to start at 3, right? We start at 3 and then we update every value here, right? But we update. Now updating every value here is also based on the column value. This is interesting. I'll end the stream and try and solve it on my own. Right now I have other things to do, so I'll continue this question tomorrow. Okay. This stream is over, and unfortunately, I couldn't solve this question right now. But I know for sure, right? It's just that one piece that is missing. This is not even a coding, because I mean, when you look at this, right, and you represent this, it looks like a rectangle. This is a rectangle with 3 points on each side, and you have, wait, we have sub rectangles in these points here. Nah, it will mean the first value of the. Alright, I'll continue this tomorrow.